I'm going to be your speaker for the first 3 minutes before we go on to the keynotes and while we wait for the other people to arrive. A couple of short announcements. So the first thing, we're going to be launching HITB Jobs today. HITB Jobs is basically a new portal, a new recruitment company, which was being put together by HITB in order to promote people who have hands-on experience. In the true fashion of HITB, we're moving away from certifications and university degrees, and we're focusing on bringing people into the workplace who have hands-on experience. You have 4 beautiful women standing outside here who are going to be able to guide you through this. They're also available for pictures, so please feel free. HITB Lab is coming on again, proudly sponsored by our friends at IBM. We've also got HITB Lab is actually, if you go to the good-looking girls and then you go 2 doors down, HITB Lab is going to be there. CTF, Weapons of Mass Destruction, looks beautiful this year. Some of the best new features that I've seen, a wonderful graphical display. They, again, are located directly next to the good-looking girls. We then have Ham Radio Village. These guys have basically come in from the Malaysian Amateur Radio Emergency Services and will, weather permitting, try and create a link between here and the space station for you to be able to talk to some astronauts. We also then have the kind people from Tool who've come back in order to show you guys how to pick the most advanced locks. Now, that's about it for the announcements. I am very, very pleased that Joe actually said to me that he'd like to introduce himself. So without further ado, I'd like to introduce Joe, aka Kingpin.
Thanks. Thank you. How's it going, everybody? I gotta get my water that was knocked over. Good catch, by the way, David. All right, my name is Joe Grand, and I'm here to talk with you guys today about hardware hacking and why hardware hacking is so cool and why it's sort of becoming this up-and-coming area of computer security. And sort of been the underdog for a long time, but it's near and dear to my heart, and it's something that I'll go through. So my name is Joe Grand. I'm an electrical engineer, hardware hacker, inventor. I've been involved in the hacker community for a very, very long time, longer than I wish to admit. I'm actually really old. And let's see. I've been involved in electronics since I was about 7, and hardware has always been my thing. While everybody else is kind of playing around with software and network applications, I've always been a hardware guy. I've loved to tinker with hardware, to open it up, see how it works, design projects. I originally started reading like Nuts and Bolts magazine and Analog and Antic magazine to learn all about electronics and just build things hands-on. So I think really the hands-on experience of working with things is really the important thing. So that actually ties into the HITB jobs. Is having hands-on experience, I think it is at least as important, if not more important, than the educational background, especially in the computer security industry. In the early 1990s, I was a member of a hacker group called The Loft, which was one of the early kind of hacker spaces, and there were 7 of us that would just hang out in a clubhouse, and we'd hack on hardware, we'd break windows, we'd set up networks, we'd do all these things. We had a bulletin board system, for those that remember modems. And it was just a place to hang out and explore technology without the risk of breaking somebody else's system or doing something illegal that could actually throw us in jail. So that was a very important time for me, since I was about 16 when I joined The Loft, to kind of teach me the whole or reinforce the hacker mindset and what you can do as a hacker as opposed to just kind of following the rules, right? It's exploring technology and doing things that had never been done before and kind of kicking the beehive to force change within the community and within corporations. More recently, I was a co-host of a television show called Prototype This on Discovery Channel. It's actually airing right now on Discovery Channel Science in Malaysia, and it aired in the United States last year. If you don't have Discovery Channel Science, you could probably go online and find the episodes at various places, and I encourage you to do so. Let's see, as far as hardware stuff, I mentioned I grew up with electronics, with tinkering with hardware. Some security-related stuff I've done, USB authentication tokens, PDAs, early PDAs, cell phones. Anything security-related has security-related problems, and I'll go through some of that. So basically, the talk is about hardware hacking and hardware, but also, so I'm going to go through like the hardware hacking process, and then I'm going to go through an example of one of my favorite hacks and one of the most recent things that I've been involved in. But before we kick this stuff off, how many of you guys are software engineers or involved in doing software programming or software analysis? A few, okay. How about on the network side? Network design, network analysis? No? Hardware? You guys all hardware guys? Who does hardware? Who tinkers with electronics or anything? One guy, okay. I think some of you guys aren't telling the truth. But everybody's involved in the security industry, right? Yeah, okay, I think that's true. All right, so hardware products, technology, we're surrounded by technology. How many people have cell phones? Come on, now you have to raise your hands. Okay. Everybody has cell phones, everybody has laptops. We take technology for granted these days, we use it all the time. Pretty much every product we use has electronics in it. And if it has electronics in it, it can be tampered with, it can be modified. A lot of times we're using hardware products for security-related applications. And most of the time, most users don't think about the security ramifications of that or what could be done when you tamper with the hardware. And that's great if you're a hardware hacker like me, going in to analyze products and find problems with products and share that information with people. But it's a little harder if you're on the design side, which I'm sure some of you guys are. Designing products is hard, especially designing products to be secure is hard. So you can take out of this presentation either tips about ways to go about the hardware hacking process, or you can take out of this presentation things not to do if you're a designer to help make your products more secure. Yeah, so hardware has always been overshadowed by the network side of things and by the software side of things in the computer security industry. But more recently, it's making a comeback, and that's why HITB wanted me to come here and sort of evangelize, I guess, about hardware and why it's so important that people start looking at hardware products. Because just because it's in a nice black box and it has blinky lights on it doesn't mean it's secure. A lot of times there's a microprocessor in there. It's running some sort of specialized firmware or software. So there's a lot of techniques that even if you're not a hardware guy, you can still go and use some of your software hacking techniques to analyze the product and break things that way. So for those of you that don't have any hardware hacking experience, why hardware hacking? These things are sort of the same for whether you're analyzing software or whether you're analyzing networks. It could be applied across the whole range, but security competency, testing hardware products for security, and to see how secure they are if you're going to deploy them in an infrastructure. Consumer protection. I don't trust the glossy marketing materials when you go to like a security expo and you have some salesperson handing out materials saying, our product is the most secure. We had the smartest guys working in a secret laboratory creating these cryptographic, our own cryptographic routines and all this stuff. Don't trust that. You need to go and actually verify that, especially if your name is on the line when you're recommending the product to somebody or you're implementing that product. You really need to test and make sure. And then what I like to do is let the public know, whether that's through an advisory or through a talk or through the media. Sometimes using the media is very useful. So consumer protection is very important in the hacker community. Military intelligence, if you're from the military side, analyzing hardware that might be encountered in the field that somebody else is using, and you find and go, what is this thing? Who designed this? Doing forensic analysis essentially against hardware, against electronics. Because every electronics designer has their own way of designing products. So you could look at, say, an IED that somebody picks up on the side of the road. You could look at the trigger circuitry and say, oh, okay, I sort of recognize how those circuits were connected or what components were used or where the components were purchased. That looks like this group. Or, oh yeah, this was done a little bit different. That might be this other group. Because I can look at boards designed by people I know and I can tell which one's which. Education and curiosity sort of encompasses the rest of the hacker ethic. Is you do it because it's fun, you do it because you can learn something. Even if you're hacking a piece of hardware, with no reason, you just want to do it, you're going to learn skills, you're going to learn things you can put in your toolkit to use in the real world when the time comes. And then, of course, you have the flip side, where there's good, there's always bad, and I wanted to include these because these are some of the common things that you'll see from a more malicious side of hardware hacking. So if you're a designer, you might want to be aware of these to protect yourself. Theft of service, obviously anything that costs money, people are going to want to get for free. So I'll actually show you an example of that. Competition or cloning. Everybody wants to make products cheaper. So some companies exist specifically to reverse engineer products, figure out how they work, and then remanufacture them, for example. User authentication, spoofing, getting access to networks, forging a user's identity. Those are sort of the main three, but there's, I'm sure, all sorts of other reasons why you'd want to break hardware. So why is hardware hacking becoming this new thing? It's been around. Electronics have been around for a long time. Software has been around for a long time. Computers have been around for a long time. But more recently, a lot of people are starting to hack hardware, and I think that's very, very good. Because I've been giving talks on secure hardware for 10 years, and a lot of the stuff that I talked about 10 years ago is still valid. Problems still exist, the same classes of problems as far as retrieving contents from memory, replay attacks, all these things that as a computer security professional you go, oh man, I can't believe people still do that. But in the hardware space, people still do that. So we can take advantage of that, but a lot more people are getting involved for a few reasons. One of them is easy access to tools. Some of this equipment, oscilloscope, a good soldering iron, used to cost a lot of money. Mostly academics would have the tools, or hobbyists with a lot of money, but now they can be purchased for a few dollars anywhere in the world. You can have your soldering iron, your multimeter, your oscilloscope. Those are like the three core tools, all you need to start analyzing hardware. So the entry level is a lot easier. Even more so possibly than software. If you're actually buying the debugging tools you need or the development tools you need for software, it can get a lot more expensive now than hardware products. Components, you can go anywhere. Let's see, with the place around here, Jalan Pasar, that street, went there yesterday. All sorts of electronic components. You can just go and get what you need. It's not that hard anymore. Logic analyzer, there's some open source solutions like the Bus Pirate when you want to start monitoring digital signals and seeing what's actually going on the lines. So you could build something for, I don't know, $20 US to do what you need. Then you have things that are a little more advanced, and I'll get into a detail of this later. Chip decapping and die analysis is sort of the next step of hardware hacking, where you're looking at the actual integrated circuit die, the silicon die inside of the black integrated circuit packages on a board, which sounds really complicated, and it definitely requires different skills than the higher level hardware hacking, but the tools are available now, and they used to be millions and millions of dollars, but now you can get the equipment that you need to perform these tasks on the surplus market through friends. I have a few links in a section later on about people that will do this stuff. You could pay $50 to have a chip decapped and have the die imaged for you. So even if you don't have the skills, you don't have the tools, you can outsource them to somebody that does, which is a new concept that wasn't possible 5 or 10 years ago. People just wouldn't outsource their services to do chip decapping and die analysis for $50. But even if you don't have those tools, you can go low tech if you still want to go down that route, and that's why people are starting to get into this. Acetone, fuming nitric acid, a microscope, just the basic tools, and you can start going. PC board design is another thing that nowadays is accessible to all sorts of people. These design tools, professional design tools, would cost $25,000 US, which only a handful of people would actually buy. Right? That's a lot of money. You really need to, if you're going to invest that kind of money, you better know you're going to make that money back. But now there's all sorts of low-cost solutions, open source. Some of them are free. That can get you in the game. You can start designing your own circuit boards, which means now, instead of trying to hand wire everything, you can use the latest technologies. You can use the latest fine pitch surface mount parts. You can create kits and then distribute those to your friends or sell those to your friends and and get the tools out there a lot easier than 10 years ago when you drew all your schematics in ASCII art and tried to tell your friends about how to build it. Now you can basically give them a kit to let them do it. PC board fabrication is the same thing. You design your printed circuit board. Now you can fabricate for very, very cheap, which makes distribution easy when you're trying to put together something. Think about mod chips for gaming consoles. That's probably the best example of easy distribution. You have a mod chip, you can distribute them very easily. There's a lot of production houses online too, so even if you're in some far reaches of the world that you don't have access to fabrication houses close to you, you can just go online, place your order, send the files. You never even have to talk to a human, and you get your files back. So a lot of the things that used to be hard for engineers and for hardware designers and hardware hackers are now just so easy. There's really no excuse not to get into analyzing hardware. Then you have things like rapid prototyping, laser cutters, CNCs, PC board prototyping machine. If you're doing a lot of PC board prototypes, you want to crank stuff out really fast. Those machines used to be $25,000 or $50,000. Some of them still are. You can create your own personal CNC, maybe for a few hundred. Make circuit boards that way. 3D printers. You can print your own objects if you need to, whether it's maybe it's some sort of holder for a circuit board while you're doing something, or I don't know. But they're cheap. They used to be $250,000 to maybe $1 million for a 3D printer. You can actually print layers of an object up, stack by stack, layer by layer. Now you can get something like a MakerBot for $1,000, or the RepRap you can build open source, fab at home. There's all these different things now that just weren't accessible. So easy access to tools. You can get the equipment. You can set up a hardware hacking lab. It's very, very easy. Easy access to information. Open source hardware is a big thing now. The do-it-yourself community is really popular. And because of the internet, there are no borders. You can be anywhere in the world sharing information. And this holds true for software and network security as well. So I left off the standard sites, BugTrack and the security sites and SecurityTube and things like that. But these are hardware related. And you can go to any of these blogs, any of these discussion forums, and see and learn something new every day. And chances are there'll be some security-related application or some security-related hack posted every day. So there's just this constant flow of information, and it's actually really hard to keep up with the flow of what's going on. Whatever area you're in, I'm sure it's like that. But there's just so much information out there now, and it's so easy. It's not as difficult as it was back in the day, where if somebody knew something, say in Malaysia, trying to get that information to somebody in the United States is going to take a long time. You got to send it through the mail, maybe call them on the phone, transfer files with a 300 baud modem. Who knows? Now information moves so fast. All the information's out there. So you have the tools, you have the information. There's no excuse not to start hacking hardware. Just a little bit of a methodology of areas that you can look at when you're hacking hardware. Just like anything in the hacker world, there's no one answer, and that's what makes hacking so great. That's what makes computer security so great. There's always problems, and there's never one answer. But this is sort of my process of going through, if I have a piece of hardware and I want to break it, what do I do? Gathering information, of course. So check the internet for all sorts of things. You got to get the hardware somehow, whether you're going to borrow it, steal it, rent it, buy it. Who knows? It really depends on your goals, right? If you need to do something covert, you might want to buy something in cash somewhere. Or if you're targeting a specific individual, you might have to go and take it from them. Hardware teardown is really the most important thing, and something that you see a lot now because of the internet. As soon as a product comes out the door, when the iPhone got released, people buy the iPhone and instantly rip it apart, take pictures, and post it online. Now there's this whole community of people that want to be the first to post pictures of a product when it comes out. And that's very important, because not only can you learn about the chips that were used, you learn about the design techniques, you can estimate how much the product cost. You can look at the circuit board right away and say, oh, are there any debug ports or any test points that I can take advantage of to start monitoring information, maybe try to inject information in. So really the goal of whatever product you're looking at a lot of times is you want to get access to the circuitry, because you start getting clues. And hardware hacking is all about getting clues. You say, okay, I know these components. This memory device is known to be insecure, so maybe I'll target that. It has a microprocessor. Maybe I can read the firmware off the microprocessor and start reverse engineering that. You get all these clues, and you might not know how they all connect until later on when you're actually formulating your attack. An interesting thing is that there's a lot of similarities between older versions of devices and newer devices. And I'll show you an example of that when I start talking about the smart parking meters in San Francisco. I couldn't get my hands on a brand new parking meter that was stuck in the street, but I could get my hands on an older version on eBay. And I could learn a lot about the new hardware by looking at the old hardware. So you don't need the latest, greatest state-of-the-art thing in order to start formulating things. Silicon die analysis, I mentioned this a little earlier. It's a subset of the hardware teardown. Except now, instead of removing the package and looking at the circuit board, you're removing the package of the integrated circuit and looking at the integrated circuit die. Very, very useful for a lot of things. Whether you just want to image the die and get a schematic of how things work, whether you want to pull out an algorithm or a security key. There's a lot of research on this. I have a bunch of links on the next slide. Whether you want to retrieve firmware, retrieve contents from ROM, flash, all sorts of things. And it is kind of this up-and-coming area where you do need some fairly specific skills, but they're not out of reach by anybody. You know, it's just practice and learning and hands-on experience is all it is. All right, so firmware reversing, say you extract the program code from a microprocessor. You have a bunch of assembly language. Maybe that's all you need. You can start looking at assembly language, figure out exactly what's going on. Or you toss it into IDA Pro or your favorite disassembler or decompiler and figure out general program structure. What I like to do is if I pull firmware contents off a board or if I pull some data off of a memory device, I don't even care what processor it's connected to. I'll just run it through strings, look at it with a hex editor. See if I can pull out any details that might give me an idea about, is there a debug menu that I can take advantage of? Is there some administrator port? Who knows? Engineers, designers leave a lot of stuff in software, whether it's in a hardware product or whether it's running on a PC. There's a lot of stuff in there that you can take advantage of. Clues. The beauty about firmware is essentially it's just software running on a general purpose microprocessor, a little computer. Pretty much everything that's electronic based is a little computer. So you don't have to be a pure hardware guy now to use your reverse engineering skills, your software skills to figure out how the software works, maybe change the code, reprogram the device, and you're set to go. External interfaces, maybe you can't get access to the circuitry. Maybe you are looking at a parking meter that's stuck in the ground and you can't chop it off and go home with it. You can't open it up on the street. So you look at the external interfaces, things that connect to the outside world. You might monitor communications of a smart card port, of a debug port. Once you do that, you might try to decode what's going on, decode the protocol. If it's serial, it's easy. If it's something else, you might have to start analyzing things. Emulating the protocol might be useful. I'll give you an example of that. And engineers like to make their products easy to design. Manufacturers like to make their products easy to manufacture, which means easy testing and verification that the system actually works. So programming ports, debug ports. A lot of times products use industry standard connections, so if you find a JTAG port, for example, an industry standard debugging interface, you can connect to that and then control the hardware. Because engineers want to leave that stuff in, and it's a real fight to get them to remove that stuff. It's sort of the whole security versus convenience thing, and a lot of times convenience wins, and things that should be removed from products aren't. Some common themes with hardware. And these are things that just haven't changed. It's just the core of electrical engineering. And being a designer as well, I can understand where most engineers in the world are coming from. They're more concerned with getting the product to market and meeting their deadlines and meeting their budget than they are about making the product secure. As sad as that is, that's just the nature of the world. So we can take advantage of that. Most design engineers either don't care about security or they're not familiar with security. In the engineering community, the pure electrical engineering community, a lot of the security books and recommendations are, if you want to encrypt something, use XOR. And that's it. That's all it says. There's no other thought given to crypto or security or anything. So it's sort of like where the software security community was maybe 10 years ago. right? It's like poor programming practices and buffer overflows and all these really obvious things, except the security industry got a little better, or the software industry got a little better. You see less buffer overflows and less poor coding practices. But the engineering industry, the electrical engineering industry, still hasn't changed. A lot of products are based on publicly available reference designs. Manufacturers of ICs, chip vendors, want you to use their products. They want engineers to design their chips into the product. So they make it as easy as possible and say, oh, you want to design a cell phone? Here's our cell phone chipset. Here's the reference design. Here's a basic cell phone. Now you as the customer can go and modify it and make it into your next generation cell phone. But the core reference design is from the vendor. We can take advantage of that. If we open up a cell phone and say, hey, that's using a Broadcom IC, we go, okay, that's a Broadcom chipset. We'll go to the Broadcom website and say, do they have a cell phone reference design? Yes, they do. Go to the cell phone reference design, pull down the schematics. All the information usually is available for free because the company wants you to use their tools. They're giving you as much as they can to entice you to use their stuff. So you say, okay, there's a Broadcom reference design. If you compare that to the schematic of the cell phone you're looking at, or of the design of your target cell phone, I guarantee you that there's a high percentage of similarity between the two. So that saves you a lot of time when you're actually reverse engineering. You can start using the reference design instead of starting with a blank piece of paper. Components are easy to identify, easy to access. They're still pretty big. You can look at part numbers. You can figure out what the part does. A lot of times you can just look at a circuit board, and without even knowing the part numbers, you can say, okay, there's the microprocessor, there's the memory, that must be some USB interface. The more products you look at, the more familiar you get with sizes of parts and where parts are located next to each other. And as long as that continues to be accessible to the human eye, you'll be able to figure out a high level functionality pretty easily. There's been a ton of high profile work going on in the hardware hacking space and the embedded security, secure hardware related space. I just picked a few that were sort of the most high profile and that the media really picked up on, but every day there's new stuff going on. And these links are just to get you excited about what's possible. E-voting machines, electronic voting. Rob's talk coming up next talks a lot about that, the process that he went through. Smart power meters, there's been recent research on the power meters that are connected through some wireless network, whether it's Zigbee or some other low-range RF. Now the meters are communicating with each other. There was some ATM cash dispensing bug that was pulled from Black Hat US this year. And the rumors were that there was some bug in a popular automated teller machine that would spit money out of the machine, sort of like Terminator 2. Of course, we don't know the details of that, but it's something that the media latched onto and really hyped up. But that's hardware hacking, looking at products that you just take for granted every day. And an ATM is a big one because there's money involved, right? So anytime there's money, people want to get something out of it. Tons of RFID research, whether it's passports, MyFair, HID, cloning, High-Tech 2. Karsten Knoll has done amazing research in this area. Chris Tarnowski. Just a lot of work. And when the media picks up on something, it doesn't really legitimize what it is, but it lets the mainstream public know about the problems. And the media has really been picking up on hardware hacking and really excited about hardware because it's a tangible thing, right? It's not a software application that somebody finds some obscure, weird bug that they can exploit through some SQL, whatever. It's a tangible piece of hardware that you can go to somebody in the media, you go to the public and say, I can spit money out of an ATM, or I can get free parking, or I can get electricity for cheaper. All of these things are easily understandable by the general public, and that's why hardware hacking is becoming more popular, because then the media writes up about it, the mainstream reads about it, and then people go, hey, that's sort of cool. I want to get into computer security. I want to start learning about things. So it's kind of generating, the media is actually helping us get more people involved to ultimately, I'd say, make the security industry better, but it just takes time. And then you have fare collection infrastructure. The Boston MBTA Charlie card was a popular one in the news because the guys from MIT that had done the work were going to give a presentation at DEF CON about breaking the crypto system of the Charlie card, which is the fare card for the Boston transit system. And Boston, being a very uptight city in the United States, called the FBI and issued a gag order and prevented these guys from actually talking about the information. A typical security or corporate response to a computer security problem, right? Every time you find a computer security problem, you're worried you're going to get sued. You're worried something bad's going to happen. You're worried you're going to get fired. These guys got sued, but what was funny is in the process of this whole lawsuit, the students had to release their information to the court. And when they did that, the information then became public. So the city tried to sue these guys from releasing information, but then the information got released anyway. So, boo to the MBTA and yay for the hackers. And then the case got dropped and all the information got out there and the kids got off. But it was, in the United States especially, the legal system is always used first. It's like you sue first, ask questions later. And that makes a lot of computer security research very, very nervous. For the next few slides I'm going to talk about, I pretty much thought I was going to get sued as soon as I released the information. And that's a bad thing, right? We don't want to have that in our community. It's better to be able to release information and help people and go about it not having to worry about all the legal stuff, right? Just worry about the technical information to get people to learn. So smart parking meters. There's just a lot of applications out there. I can't even list them all, but those are some of the core. The smart parking meters, I'm going to talk about this. I wanted to talk about a bunch of different details of hardware hacks, but I realized that I could stand up here for days, and you guys probably wouldn't want that. So cut it down to 1 hour, and my favorite hardware hack, which happens to be the parking meters, mostly because I was involved in it, and it just happened recently, so it's still cool, but also because it covers all sorts of different aspects of hardware hacking. It's not just looking at a circuit board and changing something. There's all different aspects that I covered in the process. So tearing down, analyzing, figuring out attack vectors, and then emulating protocols, all these different things. So even if you only want to focus on one part of hardware hacking, your friend might be good at something else. Then you can start teaming up and taking advantage of all your skills. So parking meters, the parking industry, the fare collection industry generates $28 billion annually in the world. Billion. That's a lot of money. And parking is one of those things that you don't normally think about, right? If you drive, you go, you pay your money, and you walk away. You don't think about all the financial problems necessarily, or social implications. If the meters are broken in a security fashion in some way that you could say remove the value and cause somebody to get a ticket, or legal applications as far as these devices are now computers, so they're not a mechanical device that's very indisputable. There's a computer. It's questionable if did it actually run out of time at the right time? So questions that you might be able to then go fight in the traffic court about. So this work I've done with Jake Applebaum and Chris Tarnowski to look at San Francisco. There's a lot more of details on the website, but this is sort of the core of what we did. In the early days, parking meters were all mechanical, and now, at least in the US, has finally caught on. Starting to move from mechanical meters to smart meters. And these smart meters are just electronic systems running firmware. There's a display. But everywhere else in the world had started doing this a long time ago. Parking meters, user interfaces. There's the coin slot, right? If you want to pay with a coin, which some meters don't even have anymore. Now you have smart card interfaces. You pay with a smart card. You pay with a credit card, which is something that a lot of cities in the United States are starting to do. And there's a whole slew of problems with doing that, as opposed to using smart cards. But I won't get into that now. Some of the administrator interfaces that a legitimate traffic enforcement officer would use are the same as the user interfaces. The coin slot, the smart card. So the same slot that you use to insert your smart card and pay for money, an administrator, especially the meters that we looked at in San Francisco, can insert a different smart card and communicate with the system that way. Infrared. The coin slot had an RF, had a coil around it, so you can actually communicate through some inductive coupling with a special reader. All sorts of stuff. Newer devices have wireless, GPRS, connecting to a cell phone network. So now you have these parking meters on a network. And I talk about meters here, but think about it with whatever product you're looking at or whatever product you want to look at. These are just this is just like general guidelines. But there's just all sorts of stuff you can take advantage of. Any single entry point or any single interface on a product is an avenue of attack. So if we're looking I read a bunch of data sheets on the parking meter, and I saw, okay, there's a coin slot, smart card, infrared wireless. Each one of those could potentially have vulnerabilities that we could take advantage of. I mean, the possibilities are just endless. It's mind-blowing. So we decided to just look at one interface, which was the smart card interface, primarily because I'd never really done work with smart cards. So I said, okay, this is going to be a good excuse to buy some tools and start experimenting with it. But we weren't the first to look at parking meters. We're constantly building on previous work, just like we are in the computer security industry anywhere. We're constantly building on previous work. New York City, New York being the place where if there's a con, somebody will figure it out to make money. And they had electronic parking meters come out in 2001, and somebody found out pretty quickly they used infrared for the audit logs, for the administrator to pull down audit logs, the usage of each parking meter. Somebody figured out if they had a universal remote control set to a certain IR frequency, a certain channel or a certain button, they could reset the value on the meter. So say you park your car, you pay your $5 for parking, you walk away, you think you're fine, and then some guy that doesn't like you walks up, removes the value, meter maid comes by and gives them a ticket. So, the person thought they were fine, and now they have a $50 ticket waiting for them when they come back. That's sort of a social implication. San Diego had a stored value smart card that Hikari looked at in 2004, a different stored value implementation than what we look at. But it's just, all of these things just shouldn't have happened. But they do. It's 2009, almost 2010, and some of these problems have been around longer than we have. Chicago had a bunch of multi-space meters recently deployed. And these are meters that are common in Malaysia that I saw, is you have one meter that corresponds to an entire block, for example. And you go to the meter, you pay money, you get a little ticket, you put it on your dashboard. So you don't have discrete parking spots. You just have, if you park, you pay your money in a meter, and you put a little sticker on your thing, as opposed to paying per spot and having a meter per spot. As soon as these things were deployed in June, there was some firmware problem or something going on where in a certain region of the city, the meter stopped working. And the media, of course, was like, hackers did this. Hackers are coming down on us. They're taking over the world. I think it was a bug in the system that wasn't tested. But it was interesting because it could have been some sort of social disobedience, some sort of hacker attack, because people were really pissed off that Chicago implemented this new meter. They raised the rates. So there are possibilities, and there are still possibilities in that meter system to take it over. A lot of other smart card hacking has been done. So again, we're building on previous work. The Dutch phone cards that were talked about in HackTick, and Rop is here somewhere who had a hand in that. FedEx Kinko, satellite TV is a really well-known one. So, we're not talking about anything new, and we're not talking about anything groundbreaking. And that's, if you're going to take home anything from this presentation, it's, hardware hacking, it's not always this, high-tech, brand new, you have to do something new. It's just taking advantage of problems that have been there for a really long time. And people, companies need to learn that. You need to kick them and say, look, you shouldn't be doing this. You got to make products more secure. So San Francisco paid $35 million to deploy this new smart parking meter system. And that's a lot of money to solve a very small problem relatively. They were trying to deal a lot with fraud of meter maids going by and opening the meters and skimming money as they're cleaning out the meters. So San Francisco said, okay, well, if we put in electronic meters that can do electronic logging and keep track of everything, then people aren't going to be able to steal anything. But they paid $35 million to fix I think it was like a 1.7 or a $7 million problem, a very small portion of money relative to the amount of money that they spent. They use a McKay Guardian meter, and there's a stored value smart card that has either a $20 or $50 value that you pay in cash, you go and buy somewhere at the store. So I was able to break this system in 3 days, looking only at the oscilloscope captures of the smart card communication. So I didn't need to know about what was going on inside the parking meter. All I had to do is go up to a parking meter with an oscilloscope in the middle of the street. In San Francisco, it doesn't matter. You can do whatever you want. Stick a smart card shim in there, stick a smart card in, monitor the communications, go back home, analyze everything, and then go and try my attack. But what we did do anyway is buy a parking meter off eBay, the early version of the McKay Guardian instead of the XLE, just an earlier version, just to get some ideas about what's possible. and they're sort of fun, part of the whole teardown. So we open it up, realize there is an ASIC, an application-specific IC, that has a Z80 microprocessor. So a very general purpose processor type that's been around for a long time. The program code is stored on an external flash device, so it's easy to remove. It's the one on the left. Easy to remove, stick in a general purpose device programmer, read the code right out. And then knowing it's Z80, you could toss it into some Z80 disassembler and get an idea of what's going on. The device was modular, which was interesting, so you could take apart different parts, the coin slot, the smart card interface. Then you see some infrared functionality in the upper left. There's this big, huge RJ45 connector that was some sort of debug interface. So we didn't have to take advantage of that, but knowing that, saying, okay, if we had access to the hardware, maybe we could use this debug interface. But what we did try to do is hook it up. I was trying to monitor the communications of that debug interface, hoping that maybe it would give me some clues how to access an administrator menu in the newer version. I didn't actually have any luck, but when the meter was turned on power up, it would send some information out of the infrared port and some information out of the RJ45 port. So it was some debug port, which was interesting. And that's something when you're looking at hardware, you got to think about that. Look for hidden test points. Look under a battery. Peel back a sticker. See if there's any pins accessible from the outside world that aren't intended for you, but probably intended for an engineer, and you might be able to take advantage of that. So information gathering, another step in the process. Jake Applebaum walked up to a DPT worker, one of the parking meter workers in San Francisco, and just started asking really dumb questions, saying, hey, how do these, those meters are cool, how do they work? Are they connected? Are they networks? Or, what do you do? And, the guy basically showed him the whole process of, here's a device I can pull down the records with, and no, they're not connected to each other. Hey, you should get a job here. And so, a little social engineering can go a long way. And then crawling the internet for information. Again, we knew it was a McKay Guardian meter. We wanted to get information as much as we could about how the system worked. So besides reading all the data sheets, we found this really cool posting from the senior software designer who was creating the parking meter, asking a question on the SIGWIN mailing list. He was experimenting with CVS and said, I'm having problems with CVS. Here's my path list. And we can see all sorts of stuff in here, and I cut out a bunch of it, but I left sort of the really bad stuff. He had a directory called ePurse. If you do a search for ePurse, that's the latest and greatest technology developed by McKay for doing their electronic monetary transactions. MetTalk is something from McKay. If you do a web search, you'll find out that's the interface for the debug administrator access. GemPlus. Right away, we know they're using a GemPlus smart card. So now we can take that knowledge, take that clue, go to the GemPlus site, see what cards they recommend for their customers to use for stored value parking. Die analysis. This wasn't necessary. This is sort of an optional thing, but we had Chris Tarnowski involved, who was by far one of the best silicon die hackers in the world, and I'd always been looking for an excuse to work with him. So it's like, hey, can you look at these smart cards for me? And he did, and he went through this process of decapping the part, removing the IC from the actual smart card. So we bought, how many did we buy? 20 smart cards from the store, and I walk into the store, and I like paying in cash for these smart cards. So I went to a hardware store that I don't normally go to, and I walk in, and I said, I'd like to buy 20 parking cards. And the guy's like, 20 parking cards? What do you need 20 parking cards for? I'm like, oh, I'm a sales guy. I use the parking meter a lot. I'm going to distribute them to my sales team. And he's like, okay. So I gave him the money, and I got all the cards, went back and sent them to Chris, and we ended up analyzing a bunch of them and realized that there's two different types of card, which was interesting. One was this early version ASIC that was hard-coded to certain functions, and then the newer version, which was pretty much indistinguishable from the exterior, was a microprocessor-based version, which means now these cards are programmable. Maybe there's hidden functionality in them. Maybe there's some commands that aren't accessible to most users that we can take advantage of. But it was just sort of interesting. But what was also cool is that the microprocessor version was probably cheaper nowadays than using an ASIC. But having something reprogrammable, we could probably take advantage of that. So just some die shots because they look cool. So what we did is monitor the communication between the smart card and the parking meter. Very, very simple. I took a microprocessor, or a smart card shim, which looks like that. The smart card pads on one side, wires going out to a socket, and then those wires are broken out to little test points that I can monitor. So I put the smart card in, put the shim into the meter, captured all the information with the standard digital oscilloscope, an Agilent scope that I happen to have, and try to figure out what was going on. So as soon as I saw the data go across, I could start saying, okay, what is it? Is it serial data? What baud rate is it? I could measure the bit width, which is 100 microseconds, and say, oh, that's 9600 baud. And it just turns out that it's a standard 9600 8E1, I believe. Yeah, 8E1 interface. So I could even hook up to Hyperterminal if I wanted to and see the data. With my scope, I actually have a digital decoding function. So once I tell it it's 9600 8E1, it will show me the byte coming across. So it's pretty easy once you have it set up. And this is the first transaction that came across, the ATR, the answer to reset from the typical smart card response. And then I can say, okay, that's a valid ATR. Now I know my protocol is set up, and I can figure out how the rest of the transaction works, start decoding everything. So I took a bunch of different cards, plugged them all in, changed values, let values deplete, and just tried to get an idea of what things on the smart card changed as I was monitoring all this information. And again, all of this stuff, you can capture the transaction on the street, then go back to your lab, and you have unlimited time to figure out what's going on. I used a pencil and paper, and I think a day to figure out the transaction. Very, very easy. So there's a few of the, there's an initialization stage. You put the card in, and there's some communication that goes back and forth. The card says, here's my manufacturer ID, here's a serial number. The serial number is used. This was confirmed by the city later. The serial number is used. It's unique to each card, and it's used to monitor the usage of the card across the city. So if you buy a $20 card, theoretically, the city knows, okay, the $20 card corresponds to serial number X, and then they can tell where serial number X was used all over the city. So they can, for privacy people out there, they're tracking you. But you'll see that could actually be changed. You can create your own serial number, and then they're not going to be able to track you. So there's some other information that goes on. The card and the meter have this interesting communication process for some of the initialization where the meter says, give me some information here. And the card sends over a bunch of information that we think is actually being used to calculate the password. And then the meter calculates the password, sends it back to the card, and the card says, yes, that's the correct password. You have access to me. And then it lets the meter communicate. So think about that for a second. If we emulate the card, we can just say, yes, that's the correct password. And then the meter will think it has the correct password, and you can just start communicating with it. So the card has control here. The card is telling the meter what to believe. And then the meter reads the balance. So the card goes in, it validates it's the correct card, and then the meter says, how much money do you have on you, card? And the card says, here's my value. I have a maximum card value that's always the same no matter what. For a $20 card, it's FFFFF0AF, and for a $50 card, it's FFFF127. And then the meter says, what's your transaction counter? How many transactions have you done so far? And then it calculates the value by subtracting the maximum card value or subtracting the transaction count from the maximum card value, and then you have X amount of units left, and I'll show you that. When you want to deduct money, once it does this whole initialization, the meter all it does is just sort of a dummy command. It just says update balance 1, and balance 1 isn't even used. So it's just a dummy command, but that increments the transaction counter. That's this read-only portion of the card. So the meter can't write to the transaction counter. It can only do a transaction to increment the transaction counter. And that's the only value that changes the entire time is the count, the number of transactions that this card used. So the card value is the balance minus 95 decimal, and then you can figure out the units. So in our $20 card, the maximum we have, it's a 25-cent unit, so we have 80 units. So what happens if we decide to change what the maximum card value is. Is the meter just going to accept that and listen to the card? We'll see. So I knew the transaction. I said, okay, let's try to replay the communication. Let's try to emulate the protocol. I didn't know anything about smart cards at the time, so I just read as much as I could about it. I had a book. I read all sorts of information, read the Hacktick article, and tried to figure out, what methods do people normally try to emulate transactions with. I tried a few different microprocessors and settled on a microchip PIC just because I had a development kit already set up with a microchip PIC. And it turns out that all the satellite hackers in the world were using microchip PIC for their smart cards. So that was really cool. And there's a bunch of tools out there that I found later that we took advantage of. So I wrote everything in C, and I wanted to use C because it's just a lot easier for people to understand than assembly language. So I said, okay, if I can use C, I can explain, essentially to anybody because it's so easy to just look and understand what it's doing, as opposed to assembly language, which is very confusing. So all the code is released, except I removed the important values, so you can't actually go and create a specific card to San Francisco. So what I did is once I was able to emulate the transaction just straight captured from the card, that's when I started changing data and saying, okay, what if I change the balance value to all Fs instead of 0 AF or 127? Does this mean I could potentially have 4,000 units on my card? No, it couldn't be that easy. Couldn't be that easy, no way. But I'll show you the result of that. So once I had everything working, I said, okay, I have this big jumble of mess of wires and everything. I want to make it a little more streamlined to really drive the point home of how easy this is. And I ended up finding something called a silver card, which was a PIC-based smart card, a general purpose microprocessor on a smart card that you can program with whatever code you want. And that's what the satellite hackers have been using. So there's a link to that. But now you go from the jumble of wires, number 1, to number 3, which is just a smart card. And it was just very, very easy to, now I have my code running on the smart card, and it looks essentially the same, unless somebody's actually looking at the image on the card. You just walk up and put the card in the meter. And this next video is funny because I was holding my 1-year-old son. I had him in one hand, I had the camera in the other, and I put the card into the meter in the middle of the city. The cars driving by and everything, and like nobody even cares. But here's the result of this whole hack. So, and because the meter listens to whatever the card says, the meter now says, oh, you have $999.99. But the beauty of this is not only can you deduct money, because the transaction counter is kept on the card, we never have to let the value deplete. So it's just the whole system's broken, right? A replay attack shouldn't happen. Being able to do this shouldn't happen, but it does. And that's hardware hacking, and that's the problem that, as designers, it's a hard problem to fix. But as hardware hackers, we can take advantage of this. We can look at any product out there and find a hardware problem with it, find a security problem with it. And that's hopefully what you guys are going to do. So HITB this year, there's a bunch of hardware stuff going on. So it's a very exciting time because there's just so much stuff. With Rob's talk that's coming up next, a lot of amazing work done. Joop de Haas and his side channel attack talk tomorrow, highly recommended, very, very cool. Andrea had done some Tempest remote keystroke sniffing that I saw his talk at DEF CON, but he has a setup here. So there's all sorts of things that maybe you'll see something somewhere that would get you excited to plant a seed, and you say, oh, I've been wanting to look at this product for a really long time. Now now I have some resources. Now I'm excited. Now I at least know a little bit of the process to get going. So if that's what you walk away with, that's awesome. Just some final thoughts. And I've mentioned these throughout. Hardware is so accessible nowadays, there's no reason not to do it. The line is blurred between hardware and software now. Now you don't have to be a hardcore electrical engineer to start breaking products. You don't need to know anything about how the parking meter worked. But if you could figure out the communication protocol, or if you could write some code to emulate that, you could be a software guy, you could do it. You can use reverse engineering techniques that you're familiar with from application development. So the lines are blurred. Simple classes of attack, very simple things: replay, reading things from memory, sniffing bus lines, injecting data contents, all sorts of stuff. and the hardware side just hasn't caught up like the software space. You know, there's still problems in the software community, obviously, but there's a lot more problems in the hardware space. New skills are being developed every day. They're being shared online. New techniques, easier ways to work with surface mount parts, for example, to assemble things, to tamper with hardware. Lots of stuffs. I always say this, the systems need to be fully tested before they're deployed. That's a lot easier said than done, but in the case of San Francisco, who's at fault? Is the city at fault for deploying all these meters without thinking about the most simple type of financial attacks? Or is it the meter vendor for selling the product, possibly knowing about how easy it was to tamper with? So the systems need to be deployed. And then the media likes it too. So if we can take advantage of using the media to get our message out there, to spread our message, you know, it will get people thinking. It will probably change the industry. Companies might start responding better by saying, ooh, we really need to fix this problem so we don't end up in the media. And then we'll also get more people involved by, you know, people reading articles and saying, ah, the hacker community, that's where I belong. And that's cool. So thanks for coming. Enjoy the show. And I'll see you guys around.